Eu acho que dispensa a apresentação, né? Então nós vamos começar com a palestra de John Maddog, que é diretor executivo do Linux Internacional. Ele vai contar como o software livre, como o open source mudou a vida dele, o que influenciou na vida dele e o que pode influenciar na vida de cada um. Então eu vou desejar welcome, Maddog.
I am in the worst part of the entire conference because I am the last speaker. I am the person that's standing in between you and having good food with hot sauce on it and 1 or 2 beers. But besides all of that, I'm still going to take my time and tell you how free software has affected my life and how I think it's going to affect your life. I would like to recognize 2 people in this talk, one of whom is a man named Alan Turing. And in 1935, he wrote a paper which basically outlined most of computer science as we know it today. He was a mathematician, he was a cryptographer. Some people credit him with at least cutting 2 years off of World War II, if not keeping Great Britain from having starved to death. And the second person I'd like to recognize is Dennis Ritchie, who was the co-inventor of the Unix operating system and invented the language C, which is the language that most of the Linux kernel is written in, as well as lots and lots of other programs. Dennis died the same week as Steve Jobs did. Everybody lauded Steve Jobs, who created a billion-dollar company, but Dennis helped to create a trillion-dollar industry. And with that, who am I? I'm really nobody. I'm a person who happened to be at a particular place in a particular time. I've been in the computer industry since 1969, which may even be before some of your fathers were born. And I've worked on a wide variety of different operating systems, different hardware. I've been a wide variety of different jobs. I've been a programmer and a systems administrator and a technical marketing manager. Although I never wanted to use the word marketing in my title, so I said I was a senior leader. Now, before we get started, I know a lot of you already know about free software, or as we call it here, software livre. But for the people that don't, I wanted to make a distinction between software livre and software gratis. Software freedom and software for free. I come to Latin America and I say to people, you should use free software. And they say to me, Maddog, all of our software is free. Because I hate to say this about you folks, but Brazil pirates 84% of its desktop PC software. You think you're heroes, but you're not. Vietnam pirates 96% of its desktop software. China used to pirate 96%, but the World Trade Organization got after them, and now they're down to only 84%. Time you. Now, I've been to Vietnam, and the Vietnamese people are very proud. Why do they pirate so much software? Why do they steal so much software? It's because the average Vietnamese person makes $4 US a day. And we tell them, you have to be on the internet, you have to have a computer in order to do business. And yet they would have to save up for 100 days with no food, no housing, no clothing, and worse yet, not being able to take their girlfriend or boyfriend out for a date. 100 days just to buy Microsoft Office. So if I was that Vietnamese person, I quite frankly would put a patch over my eye and go, R, matey. So what do we talk about when we talk about software freedom? It's the freedom to look at the source code, the freedom to change the source code to meet our needs, the freedom to distribute that code to anybody, and one we don't often think about, the freedom to use the software for any purpose. In the early days of free software, people would say, oh, I'm not going to write free software if the government's going to use it because I don't like the government. Some people said, I'm not going to write my software if the church is going to use it because I'm an atheist, I don't like the church. And some people said, I'm not going to, and it went on and on until we finally realized that nobody would be using the software for any purpose. And so we had to take the opposite strategy. We realized that it's not technology which creates morality. It has to be the moral actions of the people which determine how they use the software. And I think this is probably best applied to the National Security Agency. Now, when I talk about software freedom, a lot of people, and particularly George W. Bush, have problems with the word freedom. I hate to say that about a president of the United States, but I believe it to be true. And so a lot of times I talk about slavery instead, because people have a much more vivid image in their mind about what slave is than what a free person is. When you're a slave, you're told what to do, where to go, when to get married, when to have children. You don't own any property. You're told you're owned by the master, and they determine your whole future. You have no choice. When you're a software slave, the manufacturer of the software tells you when to install it, what type of a computer to install it on, how long they will update it, when you receive the updates, when you receive the patches, how many people can use it. And in fact, you don't own the software. You only own the right to use the software on that computer. And so if you take your computer and sell it to somebody else, the hardware to somebody else, they have to buy all new software because you didn't own the software in the first place. You own the right to use it on that one computer. And so I tell people, don't be software slaves. Have control of your software. Use free software. And people say to me, well, Maddog, I don't have the ability to change the software. That's okay. You can find somebody who has the ability to change the software and pay them to do that. This is another problem for our Vietnamese friends. Because remember, they're making $4 US per day. And they want to have a small change to, say, Microsoft Office. And they call up Mr. Gates and they go, Mr. Gates, I need a small change to Microsoft Office. He goes, oh, that'll be 5 or 6 days of my engineer's time. That's $20,000 US, please. $4 a day, 20,000. Oh my God, it's 10 years. But instead, they go down to the neighborhood university in Vietnam with 2 6-packs of beer, and they find a university student that says, sure, I'll change it for you. This is programming on their own economic level, which you can do if you have free software. Now, once upon a time, there was no concept of the professional software programmer. There was, you weren't paid to write software. You were paid to do different things, like, well, maybe you were a person in the military, you were paid to write the software to fire tanks or fire guns or things. So you were a physicist and you were paid to write the software to help to solve physics problems. Or you were a person who needed some type of answer to something, a business answer to something, and you wrote software for that, but you never were a professional programmer. And there was no concept of computer engineering or computer science or computer information science, there were no degrees. Even as late as 1973, there were no universities giving degrees in computer science. If you got a degree with something to do with computers, it was given to you by a different department. So my undergraduate degree was called Commerce and Engineering. It was half business and half engineering, and with some computer courses in the middle. Now, also at that time, all software was open source. There were no computer stores. You couldn't go down to your local corner PC store or computer store and buy some software or hardware. If you wanted to buy hardware, you would need a very large truck to haul it home. You would need to have three-phase electrical power to plug it in, and you need a 20-ton air conditioner to cool it off. And your electric bill alone would typically buy a small car every month. That was the type of computers we had, and when you designed one, you probably sold 10 of them because they would cost between $2.5 and $3 million US. And that was when $1 million in the United States was a lot of money. Now, you know, it's nothing, it's change, pocket change. And software was written to specification. I had a problem I needed to solve, and I would write down the problem I needed. I would write down the inputs which I had. I would write down the outputs that I expected. And then I would hire somebody to write the program for me. And this person would create a contract and say, oh, I'm going to write a contract, I'm going to write this software. And at the end of writing the software, you will own the software because you paid me for it. I don't own the software. You own the software. Okay? And if the software doesn't work, well then you don't pay me for it. If my documentation isn't good enough, you don't pay me for it. If you have a lot of bugs in the software, you don't pay me for it. Isn't that refreshing? And the other thing is that if you decided that you wanted to have it improved, you didn't have to come back to me. You could choose some other programmer that you thought was better. Or you could put it out for a bid, and maybe some other people would bid lower. And you would have it because the software belonged to you. That was your choice. Now, believe it or not, I was a university student one time. I was sitting where you are sitting now. And I was very young. You can see me up there in the corner. And this is the first time that picture has ever been shown in public. That really is me. And I was studying electrical engineering. I studied electronics at high school. I could build radios and things like that out of resistors and capacitors. We had transistors, but each transistor might cost $1.50. Like I said, it was a lot of money back then. Or a power transistor might cost $2.50. Imagine if we were still charging those prices today, your Android phone would cost more than the entire US market just to buy one. And when I went to college, I wanted to be an electrical engineer. And I was about 1/3 of my way through my electrical engineering program, where I was doing this thing called co-op. I would go to school for 6 months, I'd go to work for 6 months. And while I was at work, two things happened. Number one, I was almost electrocuted by 13,600 volts at 800 amps. And let me tell you, after that happens to you one time, you start to say, do I really want to be an electrical engineer? And the second thing was, I signed up for this correspondence course through my company that was called How to Program the IBM 1130 in Fortran. Now notice there, the word Fortran is all capital letters. It's all uppercase. No lowercase letters. That's because there was only going to be one Fortran. Not Fortran 2, not Fortran 4, not Fortran 77, not Fortran 90, not high performance Fortran, not distributed Fortran, not multi-thread Fortran. Just Fortran. Okay? And the computer that I was programming was that one right there, the IBM 1130. It ran one program at a time. It did not have any operating system. You linked your device drivers into your program, not into the operating system. Then basically you booted your program. Think of it like an Arduino, except it cost $1.5 million. And it had a 5 megabyte hard disk drive. Ooh. Now that was the first computer I started to program, and over time I started to realize that I was doing less and less electrical engineering and more of this computer stuff, because the most dangerous thing that could happen to you was you get your finger cut on a paper card or something. And plus it was very logical, and I liked logic. Now, all of the hardware back in those days was open. It had to be, because it was so simple and it had no operating system. So the computer companies had to tell you everything about it just so you could program it. And we had these big, thick books that told you every single thing, including the circuit diagrams of the computers, so that you could figure out how to program these. And they had no BIOS, that came way later. There were no binary blobs in the software. In fact, there was no blobs at all. And it was great. And that was the second computer I ever programmed, the BDP-8. It had 4,096 12-bit words of memory. Oh, by the way, back in those days, we didn't have bytes either. Bytes came along way later, okay? And it was even after that that they were developed into 6-bit or 8-bit bytes. For a while we had 6-bit bytes. And so a 12-bit word had 2 6-bit bytes. Of course, the bigger problem is when you cut it in half, then you had a 3-bit nibble. Okay. So in any case, I programmed it in assembly language because nobody told me that assembly language was hard. And because I learned assembly language, I also learned how the machine worked, the machine architecture. Because of my electronics background, I also knew how the registers worked and things like that, down to the transistor level. And I keep telling college students these days, that's the best type of education you can have. Learn the very basics, the very bottom of what the computer is doing, and nothing will be closed to you after that. There will be no new thing that comes along that you cannot figure out. But if all you learn are the upper level things, and you don't know what's happening below, then there will be black boxes put in front of you time and time again. As a university student, I could not afford the 100,000 US dollars it costs to buy a commercial compiler. That's how much it costs to buy, say, one copy of a compiler for COBOL or Fortran, 100,000 US dollars. And you would pay that money, and to give you an idea, a whole house with 3 bedrooms and a kitchen and a family room on a 1/4 acre of land, built of brick, brand new, would cost $32,000. And so one compiler cost 3 houses. Now, why would you pay the equivalent of 3 houses for a compiler? It's because perhaps that compiler would make your computer run 10% faster. And remember, those computers cost $2.5 million. 10% of $2.5 million is $250,000. So your $100,000 compiler is a good deal. And people say, well, why would you pay that much for your little floppy disk or CD-ROM? No. When you got that compiler, it came with a nice, big, 12-inch magnetic tape. And it was accompanied by an engineer. And the engineer would take that tape and put it on your computer and assemble the compiler until it worked on your computer system. And then it would have to pass a series of test suites to make sure the compiler was working fine on your computer system. And this could take as long as a week. And the engineer would still be there in a hotel. They'd have to pay their airfare and everything else, but it would take that long to get the compiler working, and that's why it cost $100,000 US. Now, I couldn't afford this because I was a college student. And so I ran into this organization called DECUS, D-E-C-U-S, the Digital Equipment Corporation User Society. Digital Equipment Corporation was the second largest computer company on the face of the earth. Only IBM was bigger. And they made that little computer in the corner. It's called a PDP-8. It was the first mass-produced computer. They made perhaps 1 million of them. Apple made more than 1 million iPhones on the first day. Digital made 1 million PDP-8 computers over the course of 10 years. Now, they had a whole bunch of people who bought those, using them for different things. And as I said, these people were physicists, they were scientists, they were business people, they weren't professional programmers. And they would write programs and contribute them to a library, the DECUS library. And as a college student, I could get a catalog of these programs, one paper, and I would look down and see what I wanted to buy. And I might see a text editor. Now the text editor would cost $5 US. And here's the problem. $5 US, as I said, was a lot of money. You could, with $5 US, you could buy 10 pitchers of beer. And so as a college student, I kept having this problem. Text editor or 10 pitchers of beer. I think you can see what direction I normally went. But this was free software. It was software that had no money associated. The $5 you were spending was paying DECUS to put it onto paper tape for you, to put out the catalog, to mail it to you. So I would go down to the school store, I would get new paper tape, I would run it through my ASR 33 teletype right there, and I would make a copy of it. And I would sell it to my roommates for $1 a copy. And by the time I sold 10 copies, I had paid back my $5 text editor, I'd paid back my paper tape, and I bought myself another 5 pitchers of beer. So this was a good business for a young college student. And people say to me, well, why did these people just write this software and give it away? It's because I said they weren't professional programmers. It's very hard to sell software because you have to advertise it, you have to support it, you have to write documentation for it, you have to listen to users who never like anything. Instead, if you give it away, what happens is you show up at a DECUS meeting and somebody says, hey, that was a great piece of software, it really helped me out. Let me buy you a beer. Or it was really great, it really helped me out, let me buy you dinner. Or, hey, you did a really great job on that, let me give you a job. And at the very least, you typically got somebody else who might make a change to your program and help you make it better. And now there's 2 of you working on it instead of just 1. You've doubled your workforce. This is why people wrote this software. And some people would say, well, those are just amateur programmers. They weren't professional programmers. Well, I've been in the industry for over 44 years. And I can tell you that there's a lot of amateur programmers who are just as good as the so-called professional programmers. Just like amateur footballers. I'm sure you know some of them who are as good as professionals, it's just they haven't had the chance to become professional footballers. Or amateur painters who are just as good as so-called professional painters, but they haven't had the break where they do it for fun. So the difference between amateur and professional is whether or not you get paid to do what you do. Now, I started school and started programming in 1969, but there was a couple of other things that happened. In New Jersey, at Bell Laboratories, those two gentlemen, Dennis Ritchie, the one who's standing, and Ken Thompson, the one who's sitting, decided to write a little operating system which they eventually called Unix. And that's where that got started. The same year, the United States government decided to fund a project called ARPANET. And that eventually came into what we call today the Internet. The original ARPANET address space was 15 bits because they only expected a small number of computers would ever be connected to it. Today, IPv6 is 128 bits, which means that we could have an IP number for every known proton in the universe. And the last thing that happened in 1969, little noticed except for two people in Helsinki, Finland, a baby was born by the name of Linus Torvalds, and we'll see him later. Now, eventually, I graduated and went to work for an insurance company, Aetna Life and Casualty. We were the largest commercial user of IBM equipment in the free world, which goes to show if you have enough adjectives around your name, you can be the best of anything. I am the most handsome, white-bearded man standing at the front of the room. But in any case, we used large IBM mainframes like that one there. It was actually big enough you could open up a little door at the bottom and crawl inside of it. And we had disk drives like that one where you could remove the platters and interchange platters. Each one of those disk drives cost $32,000 US in 1973. And I remember that we had 500 of them on one file on one system. Aetna automatically ordered 2 of everything that IBM announced. No salesperson had to call. We just automatically had them delivered. Now, my job at Aetna was supposedly to write reports in assembly language. I would not recommend this for anybody. Write your reports in Python or Java or anything other than assembly language, okay? But the other job I had was to make other people's programs run faster. And my experience in assembly language programming helped me do that. I would take some programs that ran in 15 hours and make them run in 5. Another program used up 15 input tapes. I made 1 line change and took only 1 input tape instead of the 15. And finally, a third program that took 10.5 hours on a computer system, I made it do the same task in 3 minutes. But I could do that because I understood the architecture and the hardware of the machine. And this is what I'm advocating that you also learn. At the same time, I would find bugs in the compilers. I remember one day a COBOL programmer came to me and said, I've looked over my code, I can't find what's wrong. So I looked at it and said, looks okay to me. Maybe the compiler is making a mistake. The compiler? Make a mistake? I said, yes. The compiler was written by a programmer like you. Like you. Maybe they were out late one night drinking. Like you, they came in with a hangover. Like you, they didn't run their test suites properly. And like you, they made a mistake. So let's see. So we turn on the little flag, and we generate the assembly language, and I look down through it and I go, there. The compiler has made a mistake. And so, because we had the source code for the compiler, we could go back in and fix it, then send the patch back to IBM. One of the other things I did was write one of the first relational databases of that time. And all of this because I knew assembly language. Now, while I was at Aetna, I went at night just to get one of the first Masters of Computer Science degrees. I told you that universities did not have computer science degrees at that time, but they were just starting to come out with a master's level degree. And I took one of the first ones. And after that, I went to Hartford State Technical College and taught for 3 years. It was a small 2-year college. We only had about 130 students at any one time. We would bring in 90 freshmen, and 2 years later we would graduate 28 people. And you say, what happened to the rest of them? They didn't do so well. Because back in those days, there were no computers in your house. They were too expensive. There were no computers in the high school. So the first time these students ever really touched a computer was in my class. And they had the strangest ideas about what a computer could do. They thought the computer was going to think for them. And wrong. And by the time they had that straightened out and realized that they would probably make a better car mechanic, that was where the bulk of the people went. But the people that did graduate were very good, because in 2 years they went from knowing nothing to be able to write a compiler, to write an operating system, to write a database, and to understand systems administration. Now, things were slightly different back in those days, because security was locking the door of the computer room at night. Networking was carrying a box of paper cards down the hallway to your friend, or maybe paper tape or magnetic tape. And graphics was putting out ASCII art on the line printer, Snoopy on top of the doghouse, various people in states of undress sitting on stools with strategically placed dollar signs. And so things were simpler. But it was also during that period that the single board microcomputers started to come out. And it was while I was at the school that once again I met Deakus, because I got software from Deakus in source code form that I could show my students, and they could use that to learn from. After that, I went to Bell Laboratories. Now, Bell Laboratories, remember Ken and Dennis, 1969. This was about, 17 or 11 years later? Yes, 11 years later, and Unix had grown a little bit. There was about 1,000 copies of Unix out there at that time, and I was a systems administrator at Bell Laboratories taking care of some of them. Now, I had never seen Unix before, but that was okay because I had a book. And that's what the university is supposed to be teaching you, how to learn from books. I had a book, and I practiced, and I became their systems administrator, and I made their systems perform between 5 and 6 times faster and reduced the cost of maintenance about 50%, because I understood the architecture and I understood the operating system. Yes, I did meet Ken Thompson and Dennis Ritchie. I actually became friends with both of them. We didn't work together closely, but I knew who they were, they knew who I was. Now, while I was at Bell Laboratories, I continued my relationship with Deakus. We had some PDP-11s, which were the computer that Ken and Dennis was in front of before. And we had some VAX 11 780s that became the workhorse of digital. The VAX 11 780s had a 32-bit address space, which meant they could have 4 billion bytes of data. The PDP-11s had a much smaller address space, and it was more difficult to code with them. I also became involved with an organization called Usenix. Now, what I recommend for you as university students is that you join the university versions of these organizations. Association for Computing Machinery, IEEE, Institute of Electrical Engineers, Usenix. DECUS is gone, but IBM has become familiar with these organizations. Join with them because they have a lot to lend you. And if you join as an association, as an organization, then the price is very inexpensive or almost free. Now, about the same time, a couple things were happening. The Apple II was coming out. The IBM PC was coming out. And Sun Microsystems was starting up. And all of these companies decided it was better to manufacture the hardware and software and make it in binary-only form. And so the people who were used to seeing the source code all of a sudden could no longer see the source code. And I remember I was at a Usenix meeting, and this person from Sun Microsystems got up and gave a wonderful talk about what they were doing and everything. And we said, great, show us the source code, let us make a copy, we'll help you with it. And he said, no, I'm sorry. I work for Sun and they won't let us distribute the source code. And the whole audience went, boo, yes. And then later on, other companies started joining in this, and more boo, hiss. And then more companies joined in, and then boo, hiss. And finally, there was so many people, it became normal, and nobody booed and hissed anymore, because people went from distributing open source code into binary-only closed source code, and they let it happen. However, there was one person who didn't like that. Oops, I went past the slide. A person by the name of Richard Stallman. He was a university student at MIT, and he liked getting the source code for Unix. He felt that there should be a way that everybody could get the source code. So he determined that he was going to rewrite all of the Unix operating system and make it available in source code form. And he started with this project called Emacs. How many of you use Emacs? How many of you use VI or Vim? Yeah, there we go. If you ever used Emacs, you would understand that probably Richard could have stopped with Emacs and just said it was an operating system. Because Emacs does everything for you. Vim is much simpler, much faster, simpler than Emacs. By the way, I use Vim, so that, But in any case, later on, he started other projects like the GNU Compiler Suite, which consists of C and Fortran and a variety of others. He started utility programs and things, and he had most of the operating system written, which he called the GNU operating system, for GNU was not Unix, meaning that Unix was something that was closed and proprietary, but GNU was something that was open and free. And the part he was missing was the kernel of the operating system, the part that controls the hardware, the part that schedules the tasks, the part that manages the memory. That part he left to last. And the reason he did was, if he had written that part at the beginning, 20 years later, it would have been uninteresting. But by starting with Emacs, he had something that everybody could use on all these different operating systems. Now, vendors like Microsoft responded to universities like yours by giving away their software. They said, oh yeah, here's our software, we'll give you student discounts, or we even give you free copies. Here, go and take a little of this candy, my little baby. The drugs are free to get you used to them, okay? And They kept saying all of our software is free to the universities, but it's not. It's not even free to universities. Why? Because the universities have people that sell them things. The universities have people who sell them paper, they sell them buses, they sell them all sorts of things. And for the universities to interact with these people use the same software the universities do. When the people graduate from the universities, they go out into the real world, and the software is no longer free. Their companies have to pay for it. And so when those companies charge the university for things, yes, the university pays again. But one of the biggest reasons, one of the biggest things that happens, one of the biggest payments, is the fact that the university students believe that when they graduate, the best jobs they can get are in different countries other than their own. And the university, which may be paid for by Brazilian taxpayers, paying to train their people to be good programmers, that money is now, in effect, given to Redmond, Washington, and Silicon Valley. So it's not free, is it? Oops. So, in 1991, the planets aligned. What happened was, the internet, the hardware prices dropped again. Dropped like a rock. So that people could say, I can afford to have a really powerful computer system in my home to work on my hobby. And the internet prices dropped like a rock. The internet was starting to come into people's homes, not just their work, not just the university, but into your homes. And documentation, white papers and things like that, even toy operating systems like Minix were there in people's homes to show them how to write an operating system. And there was massive amounts of free software from the GNU project, from MIT, from Berkeley, from a variety of places. And Linus Torvalds had turned 21. And he received this brand new computer system, a 386 computer system for Christmas. And he realized that the operating system that came with it was not the best in the world, and it didn't take advantage of everything that the 386 had. Now, students of computer history, what was the difference? What was the thing that the Intel 386 computer had that was really terrible that Microsoft, this computer company did not support?
Windows 3.0.
What?
Windows 3.0.
No.
The number of bits.
What?
Number of bits.
Close. Very close. No, he said number of bits. It's close, but not exactly right. Demand paged virtual memory. The 286 and previous computers used a type of memory management called swapping. And you could have a program by swapping in portions of it. But the 386 used a thing called demand paged virtual memory, which allowed you to have much more efficient memory management. And Microsoft did not take advantage of it because it was still trying to support all the older processors. And Linus knew that Unix did support demand paged virtual memory, but all of the Unix systems were too expensive and he didn't get the source code with them. And so he said, okay, I'm going to write my own kernel. It's just a fun project. It's not going to be anything big and complex like Minix or GNU. It's just a fun thing. Who wants to join me? And people started to join him. And they worked on it and worked on it and worked on it. And it got better and better. And people took all the parts of all these different things from GNU, from MIT, and started to put them together in what today we call the GNU Linux distribution. Debian, Ubuntu, Knoppix. These are all different distributions of GNU Linux. We're going to stop here for a second. And we're going to say, why is free software important to a country like Brazil? I mentioned before the concept of brain drain. People leaving Brazil because they feel they can only get a good job in Silicon Valley or Redmond, Washington, or London, England, or in Spain. And it's not true. You can have a good job here in Brazil. If you want to come to the United States, I'd be happy to have any one of you, maybe except for that person over there, living next door to me, inside of my house. But I want you to come for the right reason. I want you to come to experience our food. I want you to come to experience our natural wonders. I don't want to have you come because you feel you can't get a good job here in Brazil. That's crazy. You should be able to do that. And it's important that you have these well-trained people to entice other companies to come to Brazil and to create their own high-tech industries inside of Brazil. It's the security of your country. Recently, I wrote a letter to President Dilma. How many of you saw my letter? Well, the rest of you should look for my letter, okay? I thought it was a pretty good little letter. It basically said, "Hello, President Dilma. I've been coming to Brazil for 10 years now, and all I can say is, I told you so." I told you the NSA was spying on you. I told you you couldn't trust President Bush. I told you our Patriot Act means that you had no rights at all. I told you that cloud computing is really terrible when you're storing your data outside of your country. I told you all of this, you didn't listen to me. And that one article, that one blog article, I think got copied and forwarded more times than anything else I've ever written. Okay. I come from a very strange country. It's called the United States. You may have heard of it. And we think nothing about putting Microsoft software in our planes, our tanks, our guns, our war weapons, because Bill Gates is a loyal U.S. citizen. But if you're Ho Chi Minh, who happens to be dead, but if he was alive, or if you're Fidel Castro, you think twice about putting our software in your tanks, your planes and stuff, because you never know when that little trap door might be there. How many of you heard about the D-Link router? What? More of you heard about that than read my letter to Dilma? My word. The D-Link router, millions of them around the world, and there's a trap door in them because nobody could see the source code. And this is exactly what I'm talking about. And it's actually much worse than most of you would ever believe. So, you need to have the ability to keep your software working. Here's another thing. There's a little island off the coast of Florida. Maybe you've heard of it. It's called Cuba. And legally, they can't use any software from Microsoft or any processors from Intel because they were all created way after the embargo we've had against them. 40 years of embargo. Now, of course, Cuba does use Microsoft, or did use Microsoft, and they do use Intel processors because they get them from all of the United States allies. But Fidel Castro cannot call up Bill Gates and say, "Hey, Bill, I have a little problem with my software. Could you fix it for me? I'll give you a box of cigars." He can't do that because Bill Gates is a United States citizen and he is prevented from helping Fidel. That's terrible. Here's another thing, longevity. How long should your email keep working? How long should your elevators keep going up and down? How long should your cash registers keep working? Your ATM machines? Here in Brazil, there is a little bank called Banco Brazil, and they happen to have had a lot of ATM, automatic cash machines, that were being run by an operating system called OS2. How many of you have heard of OS2? How many have not heard of OS2? How many are asleep? One person had his hand back there, he said he was asleep. Okay. The thing is, OS2 was an operating system by IBM. And they just decided one day, we're not going to support it anymore. We're not going to put it on new processors or anything. And so all these banks who had all these ATM machines said, uh-oh, we have to replace all of them somehow with something else. And Microsoft had nothing for them because the machines had 186s, 286s, 386s, 486s, Pentiums, and up. And typically small amounts of main memory. So they found out that Linux could run on all of these. And to this day, on the front of every single one of their ATM machines, they have a little penguin to thank the Linux community. So longevity is another issue. And this goes into the use of standards and file formats and making sure that you have everything stored in a standard way. Now here's some more hidden values of free software. Like I said, Brazil pirates about 84% of its top PC software, but it pays for its commercial software. And so about $2 billion US a year leaves Brazil and goes to the United States, basically for software that you could pull down off the internet for free. Databases, operating systems, word processing packages, things like that. If you took that $2 billion and turned it around and paid programmers in Brazil to take free software and make it fit your needs, you're creating jobs in Brazil, and those local programmers then buy local food, pay local taxes, and buy local houses and create other local jobs. And the money keeps circulating. As soon as you send it outside of the country, it goes to Bill Gates and Dick Cheney, and there's only so much cachaça that either one of them drinks. I think Dick Cheney drinks a lot of cachaça. Bill Gates probably less. So this is a problem. And the second one is better stability in times of emergencies. Now, these companies don't necessarily stop supporting their software just because they go out of business. Sometimes there's a merger. Digital Equipment Corporation was bought by Compaq, and Compaq was bought by Hewlett-Packard. And every step along the way, software was lost. And the people that were using it had to switch to something else at great expense. I mentioned before war, embargo, and now there's something new called terrorism. What would happen to the computer industry in Brazil if all of a sudden there was a nuclear blast in Redmond, Washington, and the entire Microsoft campus and all their software was simply wiped out? How long would it take you to reinvent the software that Microsoft had if it was all destroyed in Redmond, Washington? With free software, it's on servers all over the world. It's generated by people all over the world. There's all sorts of eyes of different internationalities looking at it all over the world. So it's much harder for it to be destroyed, and much harder for something like the NSA to insert code into it secretly. So if you then talk about the importance to a company, what you're looking at is the word control. I don't talk about freedom anymore to business people because they definitely don't understand freedom. I talk about control. Business people want to have control over their business. Free software gives them the ability to make business decisions about whether to use the software as it exists or whether to change the software to meet their needs. This means that they have better control over their business and their business problems. In 1988, I bought a piece of software. I paid $1,000 for it. There was a small company near my house. They had 100 engineers and 1,000 customers. I found a problem with the software. I called up the company. I got the president of the company on the telephone. I said, I have a problem. I told him what it was. He goes, oh yeah, I know what that is, because he was the chief programmer. I said, we can change that this afternoon and send it through quality control. He could say that because he was the head of quality control. He said, if we do that, we can ship it out to you, you can have it tomorrow. He could say that because he was the head of shipping. And sure enough, the next day, I had 2 8-inch floppy disks, and the problem was solved. However, today, when you call the company, they've doubled in size. They have 200 engineers, but they have 4.5 million customers. And today, when you call the company, you no longer get the president on the line, nor the chief programmer, nor the head of quality control, nor the shipping clerk, nor a security guard, nor anything except, please press button number 1 for sales, button number 2 for support, so you press button number 2, boop, and then you get music, music, for about 20 minutes, and then you get disconnected. It's not because these companies don't want to give you good support, it's because they can't give you good support. It's impossible. They have 4.5 million customers. And if each customer turned in 2 problem reports, that's 9 million customers coming back to 200 engineers, 60,000 problem reports per engineer per year. They can't give you good support. Sometimes I speak to thousands of business people in the room and I say, how many of you have ever had a problem with closed source software? And they all raise their hands. How many of you have ever turned in a good book report to them about this? 3/4 of them raised their hands. I say, how many of you have ever gotten back a well-worded workaround or bug fix for that problem? And now all of the hands in the room will go down, except for maybe 4. And I say, Mr. Gates, you don't count. And these are true numbers. These are true numbers. And it's a sad state of our computer economy. I'll ask them one more question. I'll say, how many of you have ever had to change the way you run your business because the software doesn't work the way you need it to? And now 3/4 of the hand will go back up. And these are the hidden costs of proprietary software. Today, actually this number is a little old, today there's approximately 2 billion desktop computers, desktop and laptop. And if each one of those 2 billion computers costs us only 5 reais every day because they don't work the way they're supposed to, they get viruses, you can't install software properly, you don't back them up, whatever, that means we're losing about 10 billion reais every day as a world economy. If you had 300 people working for you and they all lost 15 minutes a day because of their computer, it means like 9 people never showed up to work. And you would be crazy mad about that. But yet we suffer it through our software. And we can't change it because we don't have the source code. You also can't see how the software works. How do you know it's really giving you the right answer? Maybe the person who wrote it used a wrong algorithm. You can't learn from looking at your existing software about how to write new software. It's hard to do research because even if you do base your research on that software, even if you say, I can deliver my research to billions of Microsoft users, It's only if Microsoft allows you to do it. And sometimes they don't. And finally, companies do go out of business. So when people talk to you about total cost of ownership of software, talk to them about the true total cost of software. Not just the cost of buying it and the cost of support, but the cost of all the other things, the integration, the education, the ongoing support, and the lack of ability to make your software work well together. Enlightened total cost of ownership means that you look at your upgrades to your software and your hardware. How much is that going to cost you? The cost of tracking your licenses. The cost of all the things that go into having to work with proprietary software. And compare that to free software. I think you'll find the costs are less with free software. But the real thing you need to concentrate on is not the cost of the software, but how you can improve it. How can the software actually make your business better, or the business of your customers better? How can it make the educational process better? And this is the thing that's really important. I give this little story. I go to a store, I buy a CD. It's on the rack of CDs that are only 5 reais a piece. I know you've seen them. You buy the CD, you take it home, you install it on your system, you start it up, it does absolutely nothing. The total cost of ownership is 5 reais and an hour of your time. The total return on investment is 0. You go back to the store, you buy another CD, 5 reais, it's an hour of your time. But when you start it up, mysteriously your dog can let itself in and out of your house without your help. Your spouse comes home, kisses you on the cheek, goes into the kitchen, makes a great meal for you, takes you upstairs to bed, and you make love the entire night. At the age of 63, that alone is a miracle. And your children come home from school, they have the best grades they ever had, and the tax collector calls you up and says, congratulations, we went over your taxes and we owe you 400,000 reais. And all of it is because of the software that's on that second CD. You don't care you paid 5 reais and an hour of your time because the return on investment is so huge. This is where free software really pays off. Let's imagine that the thing on the left-hand side is a business problem. I've been in the industry for 44 years. I've never seen 2 business problems that were the same. I go to the store and I buy a piece of software, proprietary software. I buy it in a box, it's box-shaped, X, there we go. But you know, part of my problem is still showing through. Maybe it's a printer that's not supported, maybe it's a modem that's not supported, maybe, you know, all sorts of things. I don't know. So I go to the store, buy another box of software. Oh, doesn't quite fix the problem. Go back, buy another box, another box, another box. Hey, this is getting rather tiring. I know what I'm going to do. I'm going to buy SAP. Or I'm going to buy PeopleSoft. Or I'm going to buy Oracle. Or I'm going to buy Cisco. And they will certainly solve my problem because these are big and important companies. And so I buy the software. Yeah, it solves my problem and a bunch of other ones. It gives me a bunch of other ones because I need more hardware. I need to train my people more to the software. What I really would like to do is kind of shape that like that to what I need. But I can't do it because I can't get access to the source code. How many of you think that you're here to get a good job? The universe is here to train you and get a good job? Come on, don't be scared. Put up those hands. If that crosses your mind, you're here because you want to get a good job. Put your hands up. Oh, you're so wrong. No. The university is here to teach you how to be a thinking person. how to gather data, sift through the data, and come up with information. University is here to give you a lifetime of knowledge. Not just the knowledge that's good so long as Windows XP is still supported. Because when Vista comes out, you have to come back and get a different diploma. Or Windows 8 comes out, you still have to get a different diploma. How many of you remember a company called Nortel? Ah, some brave souls. Nortel was the second largest telecommunications company on the face of the earth. It only took them 6 months to go from that to being bankrupt. And all the people that got Nortel certifications, out of luck. If instead they had learned telecommunications with Nortel as an example, they probably would still have a lot of knowledge left. The other thing the universities do, of course, is research, and public research with public money, and private research with private money. So let's take a look at a complete computer science curriculum using free software. First of all, if you'd like to study operating systems design, you can start with FreeDOS, a complete implementation of the DOS operating system with all the source code, binary compatible with MS-DOS. Very simple, get you started. Then you can go to either BSD kernel or the Linux kernel. Now, unlike the Minix operating system by my good friend Andy Tenenbaum, this Minix wasn't used by anybody to do any real thing. Linux and BSD are used by millions of companies around the world in everything from cell phones to embedded systems to supercomputers to desktop computers to servers. So when you study BSD, the source code of BSD, or the source code of Linux, you are studying the source code of an operating system that is used every day by millions of companies and even millions of people who don't know they're using it. You can learn how to write device drivers. You can learn how to change the operating system to meet different needs. You could also take a look at TinyOS, a very, very tiny and somewhat simplified embeddable system. If you want to study a microkernel, you can take a look at the HERD or MockCMU. So almost every aspect of computer science, you can see the source code, and you can play with it. You can recompile it on your computer and change it and see how your changes affect the way the system works. You can read white papers about what people did and didn't do to create the operating system. You can participate in it. You can join the kernel group. You can fix patches. You can become recognized. You can use this as part of your portfolio of software which you show to a potential employer. You'll hear more about portfolios later on. This is a world-class operating system. It is multi-user, 5,000, 10,000, 15,000 users at a time. It is multitasking, multi-threaded, multi-CPU, 20,000, 30,000 CPUs working at a time on a problem. It is multi-architecture. It works on PowerPC, the ARM processor, Intel, variety of others. And it comes in both 32 and 64-bit. Linux was 64-bit in 1995. The first time that Microsoft had a 64-bit operating system was Vista. You see how good that was. If you'd like to learn about file systems, Linux supports every file system that Microsoft has. It supports its own versions of file systems, log-based file systems, journal file systems, network-based file systems. It supports the SMB protocol, which is what Microsoft uses for its client-server type of supporting. Networking, almost every networking protocol, TCP/IP stacks, X.25 stacks, AppleTalk. It supports even DECnet, something that was a proprietary system that came from digital many years ago. All the different wireless protocols are supported. Infrared, Bluetooth. If you're interested in security, I left one off of here, AppArmor, but it supports two different major security models. One is called SE Linux and one is called AppArmor, as well as Kerberos, which is a network-based security model based on tickets. If you're interested in graphics, it has a client-server windowing system called the X Windows system, as well as supporting OpenGL and Open3D. If you're interested in clusters, whether it's high-performance clusters like supercomputers or highly available clusters for highly available systems, it supports both. And it has all the source code for these so you can see them, how they work. And the trends in Linux today are towards larger systems, faster systems, more stable systems, better compatibility, and better real-time. But it's not just about the operating system, it's about compilers. Every language you've ever heard of, there's a compiler in the free software space for it. And that includes Ada. The last full implementation of Ada is actually a free software project called Gnat. If you're interested in interpreters, all the web-based interpreters started off and exist as free software projects. Database engines like MySQL or Postgres, also CloudDB, DB Couch, a variety of other databases, and database libraries for hierarchical databases, index sequential file systems, things like that. Office systems, OpenOffice, LibreOffice, whatever you want to call it, but also KOffice and a variety of other office systems. Multimedia tools, codecs such as OGG, OGG Theora, OGG Vorbis, MPEG, WebM, all of the ones that are different and are free and open are part of open source, as well as open source implementations of proprietary patented codecs such as MPEG-4. Voice over IP, Asterisk, a complete open and free PBX, private branch exchange system, creates more telephone systems around the world than any other free and open source project. If you go out to SourceForge, you'll find that there's 430,000 different software projects out there done by 3.4 million contributors. And people say to me, Maddog, I've been out there. And you know, some of those programs, nobody's worked on them for a long time. I said, you want to know something? You're right. You want to know why they haven't worked on them for a long time? Because they're done. They're finished. They do everything they're supposed to. Don't touch them. Don't add anything to them. You'll only screw them up. If this was a proprietary program that people were selling to make money, of course they have to keep adding stuff to it to get you to buy the next copy. And you didn't want it in the first place. But you had to buy it because they dropped support of the last copy. But these are done. Donald Knuth, the creator of the TeX formatting language, said, it's done. There's never going to be another feature release, ever, because it does everything it needs to. It's done. I wish they thought of OS before they did what they did to it. But in any case, this is it. The other thing people say is, but there's all these CD players out there. How many do we need? I says, we only need one. The one that you're using. And you've got it. Don't worry about the rest of them. What do you care? You're only worried about the one you're using. People come up to me and say, which is better, GNOME or KDE? I says, I don't know. It's whatever one I'm using at the moment. I really don't care. What operates? Maddog, what distribution do you use? They all want to know. I say, I'm a consultant. I use the distribution my customer uses. If they're using Red Hat, I use Red Hat. If they're using Ubuntu, I use Ubuntu. If they're using Debian, I use Debian. I don't care. Doesn't make any difference to me. So they say, what happens if they don't know anything? Says, then I will give them a recommendation. But it depends on them, not on me. Take the distribution that you like the most. Take some time to get to know them. See which one you like the most. That's the one you should be using. So even if you don't use all of the different programs out in SourceForge, sometimes you can use parts of them. Part of a database, part of an Office system package, part of a PDF viewer, part of something. And at least you don't have to write that code and debug it. So here is the new model of software engineering we should be teaching. Not a program, but how do you write software for free and make money from service? If your name is not Bill Gates, or Larry Ellison, or Steve Jobs, although he's dead, how do you make money? You make money by installing the software, integrating the software into the customer's business, evaluating the customer's business to figure out what software they need, educating the customer about the software, and you can do all of these things with free software just as you do it with proprietary software. But there's two differences. Number one, you don't have to take a lot of that money out of your pocket and send it to Redmond, Washington. And number two, you can change the software to meet the customer's needs better. And that is the high price, high value thing that you can do over somebody who's just a software installer. Now, some people cringe with the term service because they say, oh, service is like flipping hamburgers or sweeping the street or making up the beds in a hotel. Yes, those are service jobs, and they're necessary. Anybody that does them should not be ashamed that they're doing them. But I'm not talking about that type of service. I'm talking about a service like a brain surgeon. A brain surgeon does not create a product. You don't end up with a second brain when they get done. You know, I got two brains, had brain surgery last week. Oh, here's the left brain and the right brain. You got two of them now. I think twice as much. No, they fix the brain you've got. It's a service. And yet you pay a lot for that service because you value your brain. You don't go out and look for the brain surgeon that says, I do brain surgery cheap. I don't wash my hands after each brain surgery because it saves you money. I don't sterilize my instruments. I use last year's CAT scan machine. You don't do that because your brain is valuable to you. And to the business person, their business is even more valuable than their brain. Same thing for a lawyer. God knows lawyers don't produce anything valuable. But we listen to them and pay them a lot of money because they tend to keep us out of trouble. Unless you're George Bush. Now here are the things to teach in this new model. How do you do distributed development rather than have your people travel 2 hours to and from work every day? How do you license software and get the right license for what you want to do with your model? And there are many, many open source licenses. How do you develop formal standards, and then how do you develop software above and below those standards, which is useful? How do you motivate software developers? How do you locate and engage the community of people to help you do the work you're trying to do? These are the things we should be teaching in university, because these are the hard problems. Here are things not to teach. First of all, we should be teaching fundamentals. How does a computer really work? Machine language, what is cache? How does the hardware work? What does overclocking really do? But we should not be teaching specific products, like Microsoft Office. What we should be teaching is how do you use an Office product to run your business better. And as an example, it's Microsoft Office and Open Office and K Office and all the other ones. How do you evaluate those Office products to find the best one? And you should be working on real-world projects. Don't work. The first compiler course I ever took was it's the early days of compilers. And I had key punched 15,000 IBM cards, 14,000 if statements in a row to do my compilation. And this person comes in one day with this white paper and says, there's this thing called a state-driven compiler. And I went, hui, and I threw out the 14,000 cards. Real-world projects. Nobody would ever use my compiler in the real world. But today, you can actually work on real-world operating systems that when you get out, you can show your boss, this is what I did. I can show you the source code. I can show you the email messages I sent. I can show you how I interacted with all these people, because that's what they want to see. And you can develop a portfolio of these products and show people the code because it's open code. You can't do that if you work for a closed source company. Now, Mark Shuttleworth, when he wanted to start the Ubuntu project, took the entire list of Debian down on his notebook. He put all the source code tree for Debian on his notebook, and he went to Antarctica for 9 months. He sat down in Antarctica, going over the mailing list, going over the code. When he came back, he said, I want you, and you, and you, and you to come work with me on Ubuntu. He didn't have to interview anybody. He didn't have to call any human relations people. Now, I went to work for Digital Equipment Corporation in 1983. Worked there for 16 years. I had many different jobs. I met some fantastic people along the way. If you've never heard their names, you should look them up. Dr. Maurice Wilkes, who started the EDSAC project, the first stored program computer, and Dr. Rear Admiral Grace Murray Hopper, who was actually considered to be the first real modern-day programmer, and she also was the project lead on the COBOL compiler. And believe me, when we go out for beer tonight, I'd love to tell you about both of them. While I was in digital, I always pushed for open. I didn't like using closed source projects. I didn't like working with closed source products. And I got Richard Stallman his first VAX computer system. I put out CDs worth of free software. And in May of 1994, I funded the trip for Linus Torvalds to come from Europe to go to DECUS in New Orleans. Now, if you ever go to the United States, there are 2 cities in the United States which I call the adult Disneyland. One of them is Las Vegas, also known as Sin City, and the other one is New Orleans, who earns the name Sin City. In New Orleans, you can get anything you want and a lot of stuff you don't want. And I love New Orleans as a place to go for a conference because it's great. And so I went down to New Orleans and I met this guy I'd never heard of before to see this project I'd never even heard of before, but which I had funded. And I saw Linux for the first time. And I said, this is really good. And I decided to get Linus a 64-bit alpha system so he could take Linux and move it into the alpha system, the world's fastest microprocessor at the time, and a RISC system. Now, why was the alpha important? Because Linux 1.0, as nice a kernel as it was only 32-bit, so it could only access 4 gigabytes of data, and it was only done on a CISC processor, Intel AMD. It was not portable across architectures. I wanted Linus to make it portable, and onto a RISC architecture, a reduced instruction set computer, as well as a 64-bit system. Why is 64 bits important? 4 billion sounds like a big number, but if you're doing real work, real programming, 4 billion gets very small very quickly. If you're trying to edit a movie like the Titanic or Lord of the Rings or any other animated movie, 4 billion bytes is basically one frame. But if you have a 64-bit system, you can, in one address space, have every frame of the movie in one address space at one time. If you try to design a Boeing 747 airplane, 4 billion bytes will allow you to emulate the cockpit of the plane. But a 64-bit system can do the entire airplane every 6 months of its life forever. 64 bits allows you to avoid what we call edge programming, which is where a lot of the problems in programming, a lot of the mistakes in programming exist on the edges of going from one address space to the other. With 64 bits, you can eliminate this. So I convinced Linus to do the work, and then I went back to digital, and I got it to happen. And people will tell you in your life that the way you get things to happen in large companies is you write a proposal, you get the sign off, you send it up your management chain, they look at it, they agree to it, somebody gives some money, gets in the budget the next year, 5 years down the road it happens. That's not the way you get things done. The way you think you get things done is you pull in favors. And I'd been in digital for 16 years, and there was a lot of people who owed me favors. And so I called them up, and I basically got a system for Linus that was worth 30,000 US dollars for a kid in college that nobody had ever heard of, for a project that nobody knew. And it was a very nice alpha system at a time when they were quite rare. And I put together a group of engineers at Digital to help with the alpha port. And those engineers then joined with the community, and in 9 months from the time we started the port, Red Hat Software had a distribution of Alpha Linux. This was the fastest I had ever seen a port of an operating system, and particularly done by volunteers who never met each other face to face. So I took this to Fiji in 1995. Actually, it was on my way back from Australia. I stopped in the island of Fiji to the University of the South Pacific. Your university here reminds me a lot of that because it was in a very warm place. But their university was right beside the ocean, and their professors dressed in sarongs and went barefoot. And it was very, very nice. And I gave them this CD of software that I knew represented about $15 billion worth of intellectual property, $15 billion worth of work by people who have contributed their time and effort over the years to make this. And I felt just like this. And if you notice, there's a guy in the upper right-hand corner with kind of frizzy hair. That's supposed to be me. The other people there, of course, Linus Torvalds, Alan Cox with the black beard, and Eric Raymond peeking behind Linus's neck. I went to Soweto, South Africa, a poor community of 500,000 black people, so poor that they were the people who took care of the white people in Johannesburg before apartheid. And I told them how to use free software. I also said to them, you know, I believe there are people here in Soweto who know about Linux and open source, and the government didn't believe me. We found out later that there was a guy who was actually sending email to Linus Torvalds, helping him fix a problem in the kernel. And the government was so surprised that they opened up an open source development center in Soweto. But this is more than just hardware. this thing about free and open standards. You have to have standards which are contributed to by everybody, that they happen in an even and natural way, that they're not dominated by some force that only wants to make money out of them. In HTML5, they were looking for a codec, and two companies wanted to have MPEG-4 as the video codec in HTML5. Google wanted to have either OGG or WebM, two free codecs that nobody had to pay for and that nobody had to pay royalties on the video streams. The two companies who wanted MPEG-4, Apple and Microsoft. Guess which two companies owned patents on MPEG-4? Apple and Microsoft. Free and open standards should not have any royalty-bearing patents on them. The Linux Professional Institute is a non-profit certification institute. If you can teach yourself how to be a systems administrator, you can take their certification tests at a very inexpensive cost. And finally, we get to open hardware. But before we go there, I want to talk about Creative Commons. Creative Commons is to media what free software licenses is to software. And so if you have your own pictures, if you have your own text, if you have your own movies or things like that, you can consider licensing them under Creative Commons. You notice at the bottom of every one of my slides is this little box. That little box says you're free to make copies of my slides, you're free to distribute them freely, but if you try and charge for them, you have to come back to me. If you try and change them, you have to come back to me. But you're free to distribute them in total, as long as you wish. In 1994 and 1995, we had a problem. Supercomputer companies were going out of business. We need supercomputers to do work. And so two people, Dr. Thomas Sterling and Donald Becker of NASA, created the concept of creating supercomputers out of commodity types of systems. And the operating system they used on it was GNU Linux. You can even create supercomputers out of taking regular PCs, hooked together with Ethernet, and putting Linux on it. The only difference is the operating system. And it's the same operating system that I'm using on my notebook here and that you use on your desktops. It's just they use libraries like MPI, PVM, and OpenMP to allow the different processes to talk to each other. Linux can also be used on embedded systems.